Hello, I'm Li Hao. Welcome back to Evan of Code 2023. We are solving programming puzzles every day, and today we are on day 16. So let's take a look at what puzzle awaits for us on day 16. Day 16, the floor will be lava. With a beam of light completely focused somewhere, the reindeer leads you deeper still into the lava production facility. At some point, you realize that the street facility walls have been replaced with cave, and the doorways are just cave. The floor is cave, and you're pretty sure this is actually just a giant cave. Finally, as you approach what must be the heart of the mountain, you see a bright light in a cavern up ahead. There, you discover that the beam of light you so carefully focus is emerging from the cavern wall closest to the facility and pouring all of its energy into a contraption of the opposite side. Upon closer inspection, the contraption appears to be a flat, two-dimensional square grid contained of empty space, mirrors, and splitters. The contraption is lined so that most of the beam bounces around the grid, but each tiles on the grid converts some of the beam's light into heat and melt the rock in the caverns. You note that the layout of the contraption, which is the puzzle input, like this, the beam enters the top left corner from the left and heading to the right. Then its behavior depends on what it encounters as it moves. If the beam encounters empty space, it continues in the same direction. If the beam encounters a mirror, the beam is reflected 90 degrees depending on the angle of the mirror. For example, a right forwarding beam encountered this would continue move upwards in the mirror's column. A rightward moving beam that encounters this mirror will continue downward from the mirror's column. If beam encounters the pointy end of the splitter, the beam passes through the splitter as if the splitter were empty space. For instance, a right moving beam that encounters a dash splitter will continue in the same direction. But if the beam encounters a flat side of a splitter, the beam will split into two beams and going in each of the two directions that splitter pointy ends are pointing. For instance, a rightward moving beam encounters this splitter, it will split into two beams, one that continues upward from the splitter column and the one that continues downward from the splitter column. Beams do not interact with other beams. A tile can have many beams passing through it at the same time. A tile is energized if the tile has at least one beam passes through it, reflect in it, or split in it. In the contraption below, this is how the beam of light bounces around the contraption. Right, so let me try and draw something out of this and see whether it's makes more sense. So this is what we have, right? So we come in over here and then we immediately encounter a splitter, right? So you go move up and move down, right? If it moves up, nothing else, but moving down, it hit this, right? So this is a splitter, so it goes left and right. And I hit this mirror, so you should bounce like this, and then bounce like this, and I hit this mirror, bounce like this, and then go here. And this will go a splitter, right? So this will split and split. And then when you hit this splitter, it will goes up and goes down. And that's all. So this will keep going. I think both ways is the same. So from here, we're going to go up or down, right? Down here, then it's N. But it up, it will go to this splitter and bounce like this. Right? And then it will go up. Up, and then the splitter, so it go left and right, and then done. So if it go down or up, right? So down, and then hit this thing, and then it will just continue, and that's it. But if it goes up, it will go to a mirror, and so it reflects, and that's it, right? So this is roughly how it travels. So this is the grid that has the beams that passes through. Beams are only shown on an empty tiles. Arrow indicates the direction of the beams. If a tile contains beam moving in multiple directions, the number of distinct directions is shown instead. Here is the same direction diagram, but instead only showing whether the tile is energized or not. Ultimately, in this example, 46 tiles become energized. Light isn't energizing enough tiles to produce lava, so to debug this contraption, you need to start by analyzing the current situation. With beam starting in the top left heading right, how many tiles end up being energized? Okay, this seems complex, but let's take a look and let's break it down and see how we can implement this in code to figure out which tiles is being energized by the beam, right? So let's go back to the code. So as you can see here, we have code for 15 days so far, because now we are on day 16. So all of this code is available on GitHub, and a link to my GitHub is in the description below. Right, so we are now on day 16 with puzzle 1. And let me copy let's create a variable called input, and let's copy this map. Copy this. Oops. Guess we have need to escape the double slashes. Oops. Okay, we need to escape the slash. Right, so now we escaped it. It should be correct. So let's move on. So first thing is we need to parse the map, right? So the map will be basically input split by new lines. Okay. And then we have our first beam coming in from the top left, moving from the left to the right. So you need to express it somehow, right? So let me think, how should I express this? I guess we can have the I guess we can have it that looks like something like this. Maybe like a beam, starting equals to start from, so the row is 0, column is 0, and then we have a direction, right? So it comes from left to right. So I guess the delta for the row is 0, right? So it's not moving in different number of row. But for column, DC, delta for the column is gonna be +1, right? So like this. Delta row, delta column. Oops, sorry. Okay, so this is our starting position. And next thing is we need to basically traverse the map, right? So let's see how huge our map is gonna be. This huge, right? So I'm not sure whether maybe we can start with recursively traversing through the map, and then if we run into some Stack Overflow, then we figure out whether we can going through the map iteratively, right? So let's start with just doing like a recursive first, right? So first thing is we're gonna have something called visit the tile, and we are going to visit our starting tile, right? And by the end of visiting the starting tile, we are going to figure out, so the visiting starting tile will be based on what the row, the column, the delta row, the delta column, and then figure out whether what's the next tile we're gonna visit, and then we just keep visiting them, and then by the end of it, hopefully we visit all the tiles that it can goes to, and then with that we need to figure out which tiles is currently a which tiles that the beams passes through, and we need to count how many of them, right? So if it's 46 tiles being energized, then we need to print out, right? So I guess we can have a variable called visited equals right? So the answer is basically which of the tile has been visited dot size. Okay, so now we need to visit the tile. So I think first thing first is we need to determine the logic of from this current tile, what is the next one we can visit, right? So first thing is, of course, if we visit the tile, we're gonna mark visited to add the current tile. So I'm gonna use a string like as a position, tile.row, comma tile.column. So this will create a unique string based on the position of the tile in the as a string that we added in the set, so that we don't have visited tiles. We have the if we visit the tiles again, we will not have a duplicates of the tiles that we have in the set, right? So first thing is this one. Next is that we need to figure out where we now visit based on the current tile, right? So if the row is if I think the next tile we can visit is basically based on the current tile type, right? So the current tile type is equals to the map based on the row tile.column, right? Switch. So basically different type. For example, if it's dot, if it's a vertical splitter, if it's dash splitter, if it's a like this shape, or if it's this shape, right? All have different next tile that we can visit, right? So if it's the dash, if it's a dot, right, then it will be simpler, right? We just need to continue the direction of the beam. So we're gonna next thing is we're gonna visit the tile based on row is equals to the current row plus delta row. Let me destructure this much easier. Row, column, delta column, and delta row. So this will be like this, right? Row, and then the column is basically based on the current column plus delta column, and delta row and delta column is the same. We don't change this because it doesn't change the direction, right? So that's it for a dot. But if it's for a vertical splitter, then I guess it depends on which direction the beam coming from, right? If the beam is coming from, if it's delta row, right, then if it's going different row, right? If it's of if it's going up or down, going to different row, then I guess we just continue to move on, right? This splitter doesn't do anything, right? So we are going to continue this. So we're gonna copy this logic, is the same. But if we are coming from left or right, then we're going to split into two beams. Okay, so that means that we're going to visit two different locations from now on, right? So one is the actually this one, right? Delta column, we know that if it's delta row, then which most likely delta column is going to be 0, right? If it's delta row is non-zero, then this is going to be 0, and this is just moving to the same column. But for this one, if we have different from the delta, we have some delta column, then actually we're gonna move up and down, right? So this one is gonna be up, and this one is gonna be moving down, and the other column is gonna be 0, right? We're not gonna move horizontally anymore, right? So we're gonna be having stay in the same column. And this one will be plus 1, and this one is -1. I'm going to visit up and visit down. For this case, it's the similar logic, right? So we can check first if it's moving up and down, right? Basically change in delta row, then it's the same. Then it's this logic, right? So I guess we can switch just to moving different columns left, right. Then we are not changing the delta. We're not changing the row. It's the same row, but the column will be column plus delta column, continue in the same direction. But if it's going up down, then we're gonna split and move left and right. So we're gonna stay in the same row, but we're gonna have column, basically column -1, and I guess this one +1 first, and this one is column -1, and the row we are gonna stay in the same row. So this is 0, and this is 1. This is 0. This is -1. Okay. Yep. And that's for this case. And then the next case is that if we encounter this kind of mirrors, right? So just now it's splitters, now it's mirrors. So for mirror, it really depends on where we are coming from, right? So I guess we gonna declare a few variables, right? So this is we're gonna have new delta column, and let's new delta row, right? So if delta row is equals to if it's coming from a different row, right? If it's going down, I think both initialize with 0 first. If it's coming down, right, changing different row coming down, then we're gonna reflect to the left, right? So I'm gonna say new delta column equals to -1 for the left column. Else, if delta row is equals to -1, so it's moving from bottom to up, then we have new delta column equals to, we're gonna move right, so it's 1. Else if delta column equals to 1, so which means we are moving from left to right, right? Increase in column left to right, then we're gonna move up. So the new delta row is -1. And else if delta column is equals to -1, which means we're gonna move from right to left, then we're gonna move down, new delta row equals to 1, right? So after we have the new delta row and column, next thing is that we're gonna visit based on the current row. Row equals to row plus new delta row column equals to column plus new delta column. We have the delta column equals to new delta column, delta row equals new delta row, right? Okay, and then I'm gonna break from here, and then lastly, the final mirror will have very similar logic over here, right? So if we come from the left to right, we are going to move down. So the delta column is was 1. And if we go from right, it's on. So delta row is moving down. Down, we're going to go to the right. And if it's going up, we're going to go to the left. And if it's coming from left to right, we're going to go down, which is positive. And we're going to right from left, we're going to go up. So it's -1. And then we're going to visit this plus the new delta row and new delta column. And that's it. Right? So I think that's the logic for the reflection and the splitting. So let's collapse all this. So we keep doing this, we will be never ending, right? Especially we are running into going back to the same place or going into out of the boundary of the map, right? So we need to check some boundaries before we actually able to see where to visit, right? So we didn't check any boundaries and when you go visit, but it's okay. We can check when we enter the visit function, right? So here we can check some boundary case and see if it's already out of the boundary of the map, then we just not doing anything. So for example, if row is less than 0 or column is less than 0 or row is greater than total number of rows. So what is the total number of rows? Okay, let me declare. Right, so total rows is equals map.length and total columns is equals to map0.length. So row, if its row is greater or equal to total row, or the column is greater or equals to total columns, then return, right? This is out of the map boundary, right? So this is out of the map boundary. We're gonna return, we're gonna visit. And there's another case where basically we run into previously, I'm not sure whether we might be running into a loop, right? What if you have mirrors that is looping, right? We want to prevent that as well. So I think it's a bit tricky that we can't really just treat, because the same beam can pass us through the same tiles, right? Can cross each other, right? And that's entirely possible. So we can't just check the visited whether we have passed through this tile before. We actually need to know which direction it's passing through. And it is also very tricky and interesting when we run into mirrors, right? So you can come in horizontally and go down, and you can from this direction you can go up, right? And you can come up like this direction. It's still perfectly fine, right? So we need to able to differentiate basically moving horizontal and moving vertical versus, and also like moving not just horizontal from both directions. We can actually reflex it back, right? Well, sometimes if you are on a dot, you're moving this direction and this direction. It's we don't have to move forward again, because we know that we're eventually going into the same where we come from. We'll come back. We already passed through the whole thing, right? So actually no, depends on which direction you're coming in, right? Because maybe you reflect down, and then maybe you get split down, and then you come back. You might pass us through. Not sure. Okay. But I know like if we're coming from one direction, left, up, down, left, right, from one direction, it shouldn't be coming into the same direction again on the same tile, right? That will be basically a loop. So so what is the direction? Direction is basically delta row and delta column. So we're gonna have is to check whether the uniqueness of the current row, the column, delta row and delta column. If we have this before, then we're gonna end. We're not gonna visit this thing anymore, right? So I'm gonna have another another map, another set to prevent us from moving into the same tile from the same direction, right? So I'm gonna call this visited with direction, new set, and I'm gonna, so this one, the key is row, column, delta row, delta column, right? If the visited with direction has key, then we return, right? If not, we're gonna add key. So this prevents us from going into the same tile from the same direction again. Okay, so I think we are good. We have all the logics implementing for the splitting and directing, and let's try to run this code. So I'm gonna note day 16 puzzle 1, and I have 46. So 46 is the answer, right? So I guess our reflection logic works. So now we're gonna have the actual puzzle input. Oops. So this is the puzzle input. This looks huge. Let's copy and see whether we are able to run this. One thing we need to take care is we need to escape all the slashes. Hold on, let me go to new file. Okay, and from here we're gonna, okay, and let's copy this, come back and paste it in, and let's run our code. Okay, seems like we don't run into Stack Overflow, so it's okay. Well, good. Let's paste this in, submit, and yes, that's the right answer. So we have solved part 1, we got our 1 gold star, and let's move on to part 2. So continue part 2. Okay, let's see what awaits for us on part 2. Hold on, come a bit slow. Okay, so part 2. As you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to a nearby control panel. There, a collection of buttons let you align the contraption so that the beam enters from any edge tile, lets you align the contraption and heading away from that edge. You can choose either of 2 directions from the bottom if it starts from a corner. If the beam starts in the bottom right corner, it can start heading leftward or upward. Right, so the beam could start on any tile in the top row, any tile in the bottom row, moving upwards, any tile from the leftmost column going to right, and any tile from the rightmost column heading to the left. To produce a lava, you need to find a configuration that energizes as many tiles as possible. In the above example, this can be achieved by starting a beam in the 4th tile, in the left in the top row, from the left in the top row. From the top row, 1, 3, 4, right? So maybe coming down from here, right? 0, 1, 2, 3, 4. Using this configuration, 51 tiles are energized. Find the initial beam configuration that energizes the largest number of tiles, and then how many tiles are energized in that configuration. Okay, so I guess we just need to have the same code logic, but we're gonna try coming in from different angles, different positions, right? Hopefully that's not too difficult. Let's try and see, right? So I'm gonna copy, duplicate this code puzzle 2. Let me copy out this first. In the meantime, before I replace it with the example inputs, right? This is the example input. So we didn't make any change in the code anywhere. I guess the only thing we need to do is we need to find the largest value of the visited sites, right? So from starting from here, I think everything is we can reuse almost everything from here. And this, I'm gonna create a function called count get count energized tiles, right? Based on the starting tile. And then we have this visited, the direction, visit, and then this is the return value. And then we have all the whole function in here. Let me copy this in. Right, so everything is in here. Okay, so this is the count energized tile based on what is the starting tile. And now what we need to do is we need to find the maximum energized tile. We start with maybe 0. And then we need to print out the answer, maximum energized tile. And so here we need to loop through and find out what is the based on different starting tiles, and to find out what is the maximum energized tile, right? So we can go the top row first, right? So we'll start from let column equals to 0, column less than total columns, column plus plus. So here we can try to find count energized tiles based on row is 0, column, and then the delta column, the delta row, because this comes from the top, right? This comes from the top, right? The 0th row. So the delta row is going to be going down. So it's 1. And delta column is going to be 0. Right? So we have this value. And we need to basically find the maximum, right? So I'm going to say this equals to math.max current value with what we can get from the top. And since we're looping to find the every column based on the top row, we can actually do the same thing for the bottom row as well. It comes from the bottom, right? So this one is the row will be actually the total row minus 1. And then we are actually moving up. So this is 0. So we do this. So keep finding. And then we're going to have the same loop, but for rows instead. So that this will give us for total rows. This will give us from the left and from the right. Right, so first thing is comes from the left. The left will be basically what row it is, but the column will be starting from 0. The delta row, we don't change. Yeah, because coming from the left, delta row is 0, and then column is plus 1. And then comes from the right. This one gives us row. And then column is total columns minus 1. Then delta row is 0, and then column is minus 1. Right? And then we basically, at the end, we print out what is the maximum energized tile. So let's run this code. Day 2, 25. Wait, that's not the answer, right? I don't. Oh, hold on. I need to escape this. Okay. Let's run again. Yeah, 51. And 51 is exactly the same as what they say in this one. So let's try to run this with the actual puzzle input. So here, let's replace this puzzle input. Save this. To run this. Takes a while, but we solve it. 8183. Is this the correct answer? Let's paste this in and hit submit. And yes, that's the right answer. So we have solved day 16, and that's our 2 stars for today. So we left. Now we're gonna go for day 17. So we're gonna see you in day 17. Bye bye.